Before you begin watching this video, you should have at this point downloaded this picture of this Earth, and you had a question to answer. If this was the size of the Earth, you were to draw how big you think the atmosphere would be on this sized Earth, and then submit that back to your instructor. If you haven't done that, stop the video and go back and answer that question. If you've done it, that's great. Let's move on. So let's review what we talked about last lesson. Matter is stuff, and atoms are the smallest piece of stuff that we can have. You can take stuff then and describe it a number of different ways, two ways in particular, physically and chemically. Physical properties are what our senses can detect, and chemical properties are the ingredients of the stuff that we're talking about. Now you can take the stuff and change it. You can physically change it, which means you can change it and then go back, or you can chemically change it, and once you do that, you can't change it back. You can also take stuff and combine it together. When we combine it in such a way that we can pull it back apart easily, that's called a mixture, and it can be split. If we take chemicals, though, and combine them in such a way that they can't be split apart, that's a compound. Compounds are things that can't be split. Well, we're talking about air in this class, and air is an example of a mixture, and last time we went over the chemical properties of that mixture. Now going back to 340 BC, that's the first real articles of people studying the air. Aristotle wrote that, right? Basically, that's meteorological, from the word meteors. Meteors in that language is from the sky. That's 340 BC, but it wasn't until the 1600s that we had instruments created to measure the physical properties of the air. In the 1800s, the telegraph lets us share these observations in real time, large distances away. And weather forecasting really starts to take hold in the 1800s, though it's really poor. World War II, we were fighting a war over in Germany where we wanted to know where airplanes were. So we had radar looking for airplanes. And at the end of the war, we had all these extra radars lying around. So what do you use them for? Well, they discovered in World War II you could really use them well to detect rain, and there we go. Radar can detect rain. In the 1960s, then we launched robots in space and cameras in space, and then there's computers to help us look down at the Earth to see exactly what's happening. The advent of satellites and computers get us to where we are today in modern forecasting. But that gets me then to the question I had for you before this lesson. It was a question about the physical property of the air. How thick is it? If you take that paper globe, how thick would the atmosphere be on that small little Earth? Most people, when they answer the question, give an answer something like this. Because when you look in textbooks at models of the Earth, they show this little fuzzy area around the Earth of the atmosphere. Well, the true answer is you could not physically draw the correct thickness of the atmosphere on this globe. Even with the thinnest pencil line you could make, that's still going to be too thick. I upped the ante a little bit. This globe in front of me is a lot bigger than the paper globe that I had you complete. And if I got a piece of cellophane like this and put it over the Earth right here, even this is way too thick of an atmosphere. So now you might be wondering, well, I look at pictures from space, why is it so thick? Look at this one. There's a picture from space, and you can actually see a thick little fuzziness to the atmosphere right there. But really look closely at that picture. How big would that globe need to be? Extend that circle off your computer screen, your tablet, or whatever you're watching this on. How big would that Earth need to be for that atmosphere in that picture to be what? A pencil lead thickness? The atmosphere is extremely thin. If you had a tall enough ladder and you were physically fit enough, you could climb out of the atmosphere in a matter of 1-2 hours. If we had a highway that went straight up, you could drive out of the atmosphere, the majority of the atmosphere, in minutes. Rockets do it in seconds. So as we go through the upcoming lessons, we're going to look at that atmosphere and break it down and see what exactly makes the air here on Earth tick.